Alright guys, in this video I'm going to go through the concepts of buffer solutions. So a buffer solution is one where the pH does not change significantly if small amounts of acid or alkali are added to it. An acidic buffer solution is made from a weak acid and a salt of that weak acid, made from reacting the weak acid with a strong base. For example, ethanoic acid and sodium ethanoate. So this sodium ethanoate is made by reacting something like ethanoic acid and sodium hydroxide, and then you get sodium ethanoate, which is a salt of ethanoic acid. Okay, so we have a weak acid and a salt of that weak acid. So when you're looking for an acid and it's salt, you just look for the names. So ethanoic acid and ethanoate. So if we had methanoic acid, we would look for sodium ethanoate. A basic buffer solution is made from a weak base and a salt of that weak base, made from reacting the weak base with a strong acid. For example, ammonia and ammonium chloride. Alright, here I've got a beaker, and these are the reactions happening inside an acidic buffer. So I'm going to call this reaction reaction 1, and this reaction 2. Okay, so it's important to know roughly what you have high concentrations of and what you have low concentrations of. So this reaction here, reaction 1, is in equilibrium. However, ethanoic acid barely dissociates, so that means you have a high concentration of ethanoic acid and low concentrations of ethanoate ions and H+ ions. However, in reaction number 2, we know that this ion here completely dissociates, so that means from this reaction we get high amounts of ethanoate ions. Therefore, we have high amounts of ethanoic acid particles floating about, and we have high amounts of ethanoate ions floating about. Okay, so when we add H+ ions, these ions react with the ethanoate ions, and then the equilibrium shifts to the left. However, we already have large amounts of ethanoic acid, so even though the equilibrium is shifting to the left, the concentration of ethanoic acid doesn't change by that much. And even though ethanoate ions are getting used up in this reaction, we said we have high amounts of ethanoate ions because of reaction number 2. Therefore, the concentration of ethanoate ions barely changes. Now this is only for small amounts of acid added. If you add a large amount, well, the pH will change. Okay? So it's important to remember the pH doesn't change only when it's small amounts of acid or a base added. Now what happens when you add a base to the buffer solution? Well, the OH- ions react with H+ to form water. Because of this, you lose H+ ions, which decreases the H+ concentration. Therefore, the equilibrium shifts to the right to regain all the H+ ions that you just lost. Therefore, the pH does not change because the H+ concentration has remained constant. Okay, and that's because the equilibrium shifts to the right. Now you also need to know what happens with basic buffer solutions. Once again, we have reaction 1 and reaction 2. Now reaction 1 is in equilibrium, and we have high amounts of ammonia and high amounts of ammonium. Now when we add H+, these H+ ions react with OH-, and the reaction shifts to the right to regain all the OH- ions that you just lost. Therefore, the pH doesn't change because the OH- ions react with all the H+ that you have added. Now what happens when you add a base? Well, the OH- reacts with ammonium, and this is basically the backwards reaction of reaction number 1. So then the reaction shifts to the left. However, we have high amounts of ammonia already, so shifting to the left doesn't really change the concentration of ammonia. Also, we have lots of ammonium ions, so we have more than enough ions for the OH- to react with, if it's only a small amount of OH-.